looks like it's an ace. Yeah, it's not one. Yeah. I need to explain this. Yeah, there we go. Yeah, no, I've got that. Yeah. Oh, sorry about that. We just checked that I'm actually recording here. So, oh yes, look at that. Which microphone? Yeti stereo. Brilliant. Yeah, sorry, I'm just getting confused about how I did the recording. So we're trying to do a recording on Zoom to supplement whatever's being recorded off there. A little bit late stuff. Close the door. Okay, so welcome to machine learning in the physical world. Well, welcome to the start of term as well. Maybe first lecture for some of you. So it's going to be taught by myself. I'm Neil Lawrence and Carl Henry. And we sort of share the lectures equally. This is the course website. So it's ml@cl.github.io/mlphysical. And what you'll see, I mean, it's linked from the Moodle. And you'll find here a few things. So there's a little Reddit forum if you want to try and discuss the course there. The hope is that we maybe trigger some discussion. You can answer each other's questions. There's the set of lectures, which is here. And each of those lectures, so this is today, that'll be tomorrow, that'll be, sorry, Tuesday, get that right? That'll be next Thursday, so on and so forth, going forward for the first 5 weeks. Now, after 5 weeks, what we do is we're going to switch the form and give you a set of case studies. So the way that the principal manner of assessment for the course is that you do mini projects in small groups. And those mini projects are based around what we're teaching in the main course, okay? So in order to inspire you over what those mini projects could be, we have a series of sort of guest lectures of people coming in, talking about the sort of thing that you might be interested in doing with a set of techniques that you've learned. So there are old case studies up, but they're case studies from previous years. So you'll also go in here. So Minnie Scott, for example, this case study. This is an interesting one because we haven't made the video public because this was an old colleague of mine from Amazon who came and gave a talk about the Amazon supply chain and how that operates. And what Jordan, the great guy, has done is create, and it's linked from here, an Amazon supply chain environment that simulates the Amazon supply chain for people to be interested in. But Jordan didn't get permission from Amazon for us to share his YouTube video publicly. But I do have the video, so we can replay that for a case study session if people are interested in that. Or we can ask Jordan if he'd be willing to. He did it via Zoom because he's based in Seattle. So it's the same effect as if we just replay it. So that's one of the case studies. But you'll see that there's a few other case studies in the same. So climate science challenges and elasticity data. And this year, I think we're going to do. We've got some on ice sheet modeling lined up, and we've got some on machine learning model training, because it turns out that everything we're doing can be seen as, you can view training machine learning models as an example of what we're going to study. So back to the lecture. So this week's an introductory lecture, so the motivation stuff. Each lecture comes with, at the top, my lectures. Carl Henrik does it differently, if he likes to do it differently. He's a bit of a hipster. So Carl Henrik does it differently, but the way all my lectures, so that you've been taught me before, if you're in the part 3, and you may have been taught by me in part 2, you'll also recognize some of this, but you see the fancy new style. Are you all impressed by the fancy new style? Yeah. At the top, we have links. Now these links, so each lecture, and it's not that much use today, comes with a Jupyter notebook that allows you to recreate the little experiments that are done in the lecture. One way of accessing that Jupyter notebook is to open it in Colab directly. So that link takes you to the Colab thing. So what you'll see is, when it eventually comes up, is exactly the same sort of set of notes. One thing I advise you always do when you open this is you click View, Expand Section, because Jupyter Colab seems to collapse sections, something that Jupyter Notebook won't do. And then you'll see that basically what's on that web page is also here, but there's also cells for rerunning all the code. So you get the notes in these sort of two different forms. And then the slides, if you want the slides, yes, you can see them here in a little window. But if you want to see them full screen, just click on there. Okay. So, oh, I can unfull screen it. Oh, is it? No. You see, it's too long. I've forgotten the key command. There we go. So with that, I'll just pause and see if there's any questions or things that are not understood about the course, and then I'll start getting on with the introduction to the material. All good?
Is there a cap?
Is there a what?
A cap for how many students can be in the course?
A cap. The main cap is like how much we want to mark. Don't mind talking to people, that's easy. And I think there's not restrictions on, we used to have restrictions on the lecture size, but now we're okay. So I think we've got quite a lot of students auditing, is that right? Hands up if you're auditing, yeah. So look, if you're not auditing, look at them, be jealous. But they don't receive the full experience because a lot of the experience is to actually do the work. Yeah, so there isn't, is there a cap? From our perspective, there isn't, but there might be stuff at departmental.
Exactly. So I think there is some number. Why this question come up? Are you not
Yes, on the website it says 30 students. This is way more.
Oh, that's because of the marking. We don't want to mark more than 30 students worth of project work. Yeah, yeah, that's like.
It limits, like, it's really useful to do a group project on this, and we wouldn't be able to do that. And it's simply the assessment where they will be that 30
But I should say the courses, and I hope there's lots of diverse range of people. The course was designed specifically in the knowledge of two programs that run at the university. One was the AI for ER CDT. So yeah, look, people go, yeah, it's like yeah, call out, shout out to AI for ER. Yeah. One's the AI. I mean, they didn't. So I think it was probably just before you arrived or when you arrived that I heard about the CDT. I didn't volunteer to organize courses for the CDT, but I thought, oh, it'd be cool to have a course that they could use. So it was designed in the knowledge that that was existing. And then the other one is the Accelerate program for science. So the Accelerate program is a Schmidt Institute funded program, which is to accelerate science through artificial intelligence. So the aim was to have a course that would be suitable for our Part 3 and MPhil students to do sort of computer science work on, but would also be of interest to pretty much anyone who felt comfortable in coding and was interested in a particular domain across the university. So we're very open about inviting all those people in, and all the lectures from past years are online on YouTube, and we'll put this up on YouTube as well. I mean, so if you've got, you know, don't mention it now, but if you've got any issues with that around being shared, let us know, because what we try and do is switch off the video and then do questions at the end. But if you're like worried about being, it's only the video that's coming off Zoom, so it's basically a view up my nose is what you get. So it's me that should really care about it being on YouTube. But if you've got any objections to that, let us know and we'll work through those. But we're trying to make the material as widely available as we can. So you can also look at previous years, see if we teach it differently, if you like. Other questions? Because I prefer.